Okay, so here's where we were before when we left off. We had talked about curly braces and how that sometimes elicits religious debates about where curly braces should be. And my advice to you on that is there are good standards for curly braces and probably bad ways to do curly braces, but there really are two that are heavily used and considered to be good ways to do curly braces, and it's the top two that are bold. The top one is the standard for Java, and the one below that is used for quite a few other languages. C# uses this one, and some others do. And the main thing that I would say about curly braces is we probably can all have our opinions about what we think looks good, but it's better and much more useful for us to decide to follow the standard. So if our team or our company has a standard, we should follow that for sure. That should be our number one priority. That way our teammates can easily understand our code, and it just is a big benefit to our organization. If our team or our organization doesn't have a standard, then we should follow the standard of the technology that we're using, the programming language. Again, even if that's not the standard we would prefer. And you really only should make up your own standard if there isn't one of the others. If there isn't one for your team, there isn't one for your company, there isn't one for your language. All of that's unlikely, but you know, if there aren't standards like that that you should follow, that's the point where you might kind of make your own standard. Maybe a team makes their own standard, something like that. Okay, one other thing to say about curly braces. If we look at this code, notice that that is a for loop that has just one statement, which means it's legal not to have curly braces around it. But most people would say, and I agree with them, that that's a bad idea. So it can make your code more compact, but more compact is not what we're after. What we're after is more maintainable, higher quality, better code, easier to read, easier to change. And all of those things are made worse by not having curly braces, even in the cases where you don't have to have them. So for example, if you only have one statement that needs to be part of a for loop, or one statement that's part of an if, or one statement that's part of an else, you technically don't need curly braces. But that makes the code more confusing, and when we're maintaining that code, there are a lot of situations where it becomes unclear. Sometimes you look at it and say, well, I can tell that this one statement is the only one that's in the if, but based on the indenting, it looks like the author intended for other statements to be part of it too. So is that a bug or just bad formatting? And you don't really have those questions come up if you just use the curly braces, even when you don't have to. So that's a really good standard to follow, and most standards, I think, would tell you that you should have curly braces even around single statement blocks. Okay, we can use spaces to make our parameters a lot more readable and easy to understand in method calls, and there are two main ways to do that. So first of all, this top one is a bad idea. We definitely don't want to have everything just strung together with commas. We at least want to have a space between each parameter, like you see in this third example. And then a lot of people like to have a space before the first one and a space after. That one is more of a preference than anything, but if your team or organization has that standard, then you should follow it. So that's a case where I would say follow the standard, but either of these two are generally considered good and acceptable ways to do it. But you really shouldn't mix and match either. Your code should have all this or all this, and if your team or company has a standard, you should follow that. Okay, we want to declare each variable on a separate line, and there are a couple of reasons for that. If we look at this code right here, this is C or C++ code. But if you look at this is kind of a question of what we intended. Right here we have an integer pointer called P and just an integer called Q, but is that what we intended? Maybe not. Maybe we didn't understand the syntax well enough and we actually thought that made both of these pointers, but it doesn't. So that's a case where it's not good to have that question, and we wouldn't have that question if we declared both of them on a separate line. So we want to declare each variable on separate lines. Similarly, we don't want to have multiple statements on the same line. So we could do it, the language allows it like this, most languages do, but it's better to do this, to have each statement be on its own line and your code is much more readable. Especially if these statements get long, it's really easy to miss the fact that there are two statements and to think that you're only looking at one. And people are used to looking at just one statement per line. So that's a standard that you should follow. We want to wrap long lines, but the question becomes, when should we wrap them? So at least when they won't, when they don't fit on a screen, you probably want to wrap them, but screen sizes can be different. So again, it's not really clear exactly when we should wrap them, but it's common to wrap them between 80 and 100 characters. So have some point, some number of characters. Again, have a standard that you and your team hopefully are following, and then just break lines when they get to that point. And we usually want to break them at a good, like the beginning of a variable name or something like that, beginning of a parameter name, before we reach whatever our maximum is. And then we want to align our continuation lines in a way that makes it easy to read. And again, there are a couple ways to do that, but we want to have some good way that we do that, that we follow. So here are a couple of ways we can do it. Notice these are indented, but this is not just indented, but it's also indented to a tab point, or this one is indented to align with the one above it. And really, you could do either way, but again, you'd want to have a standard and follow it and be consistent about how you follow it. And then typically, if you're not, so this is parameters and showing how we usually will indent them. A lot of people don't, a lot of people just tab them in, but they're easier to read if they're tabbed clear into the parentheses. And then if you just have a line that you're breaking that's not a parenthesis list, we'll typically just space it in 4 spaces or a tab. Usually 4 spaces are better, but you could do that either way. And then right here, you can see that we have aligned these items, makes them more readable to align them. Okay, let's look at pseudocode. So when we're writing something that's complex, it's a good idea to write an outline of the method before we start. And so that we might write in pseudocode. We use English-like statements to describe it, but we don't want to do it in the syntax of the language itself. We want to, if we're doing that, then we're probably describing it at too low of a level of detail. So we want to write it at a level of detail that describes what the algorithm does, not all the specifics of exactly how it does it. And so I'll show you good and bad examples of that. So we want to do it at a low enough level of detail that it's pretty easy to generate the code, but not so low level that it's as complex as the code. Okay, so here's a bad example. If we look at this, a couple of things that are wrong with this. It's hard to understand. Pseudocode should be easy to understand. We're using words from the programming language, malloc, so that's from C. And if you look at it, we might as well just write the code for this. It includes so many details that that's probably not simpler than the code. The reason to write pseudocode is to describe an algorithm in a way that's easy to understand without getting bogged down in all the details. So that's probably useless as pseudocode. Here's a better example. So this is written in English. It's not specific to a programming language, and it's written at the intent level. So it's written at a level where we can tell what's intended, but it's not so detailed that we might as well just write the code. And so then the question could be, well, when should I do pseudocode and when do I just write the code? Well, if the algorithm is complex enough that pseudocode helps to make it more understandable, then we might do that. We might describe that in some document to describe the algorithm in pseudocode. But if it's pretty simple, we wouldn't want to do that. We just write the code. Okay. Another thing is we want to have good variable names. We don't want to have something like this, number of people on the US Olympic team. That's pretty obvious to us that that's really wordy and it's a lot to read. And if you have a lot of variables that are that long, then it takes you more time to understand the code. But on the other hand, N, what does that mean? You can't tell by just looking at that variable what it means. So that's too short. So something like num team members or even number of team members would be about right. So that would be a better way to name that variable. There are a few cases where short variable names are good. Generally, they're not. Generally, a one character variable name is a bad idea. But by convention, we often do it in loop control variables. So we'll often, in a for loop, we will create an index called I which stands for index. And then if we have a nested for loop, we just kind of continue from there. So I is the first one, J is the next one, K is the next one. Or we might use something like IDX. Those are good for loop control variables, but not if they're used outside of the loop. Temporary variables, not a bad idea to name a variable temp. That's pretty obvious what it is. And then there are some variables that are naturally short, like X and Y coordinates. There's not a better name for the X coordinate variable than X, probably. So there are cases where really short variable names can be good, but those are more the exception than the rule. We want to follow good naming conventions. And again, what I recommend is follow the naming convention of the language that you're using. What's normally used for that language is the best convention to follow. And so we can have conventions about how we separate words. A really common one is what we call camel case, where it's all lowercase except the first letter of each word. And sometimes the first letter of the first word is lowercase. In Java, the convention is camel case, where with classes, it's first word of every letter capital, class names, but for variable names, the first letter of the first word is lowercase. And that also allows you to distinguish easily what's identifying a class versus what's identifying some variable. There are standards where you might use underscores, and in certain languages that's common. In Java and C and C++, those conventions are all pretty much the same. Generally, we only use underscores in those languages for constants or in Java final variables. And in those cases, we usually make the words all uppercase. Let's see. I think that's all to say about naming conventions. We want to make names be readable and clear, because the whole idea is that people can understand your code, and it makes it easier to maintain your code. And it's easier for you to understand your own code later. So it's not just a benefit to somebody else reading your code, it benefits you when you need to read your code. So make sure that the names are related to the thing that you're trying to name. We definitely don't want to have variables where the only difference is capitalization. That's really unclear, so definitely don't do that. And things that are different meaning but similar names, again, it's not a good idea to have the names be similar. Temp and temp, those are so close together that it's really easy to get confused when you're seeing the variable in the code and think you're seeing one of the variables when you're actually seeing a different one. So again, that's not a good idea to have very similar names that have different meanings. Good idea to avoid words that are commonly misspelled. And this second one I think is pretty important. Avoid characters that are hard to distinguish. Like in code, you can't tell the difference between a 1 and an L usually. So just have that in mind. Avoid using digits. Sometimes it's a good idea, but usually not. Source and destination file is better than file 1 and file 2. But maybe if you're comparing two files, maybe file 1 and file 2 is as good as you can come up with. In general, though, we'd like to not use numbers to distinguish variables. We'd like to use something more descriptive than that. The last thing I have to say about coding conventions is abbreviations. So we don't want to overuse abbreviations. Only abbreviate when you need to. But if you're going to do it, one of the things that you can do is remove long leading vowels. It's pretty clear that CMPTR would be computer. Our minds see those kind of things pretty easily. We can use just the first few letters of the word, like calc for calculate. That becomes a pretty easy to understand abbreviation. But if you look at this one, why take the E off of name? It doesn't really provide any benefit. It just makes things confusing. So not a good idea to do that. And we want to make sure that we can pronounce things pretty well and definitely be consistent in the abbreviations that you use. So if you're using a variable with the same name, don't abbreviate it one way in one class and a different way in another class. That just gets confusing. Okay, so that's not everything that can be said about coding conventions. There's a lot more to it, but if you'll follow those conventions, then people will think that you have clean code that's pretty easy to understand. And that's the important thing, is that it's easy to understand, easy to maintain, and easy to modify, because more money is actually spent modifying code and maintaining it over its lifetime than the amount that we spend initially writing it. we can reduce that cost by having our code be clean and clear. So you definitely want to follow conventions like this. And after a while, it gets to be a habit where you don't really have to think about it. It's just how you write your code. Okay, so that's all I have to say about writing quality code. Are there any questions or any, this is a little bit more fun lecture when we can do it in person and find out how people feel about different things. That's kind of harder to do remotely. But any questions or any thoughts about any of those standards that we've talked about?